For this lesson, we're going to be continuing looking at trigonometric ratios and how we can use trigonometry in right-angled triangles. So what we've covered so far, just the trigonometric ratios themselves. We've got our definitions of sine, cosine, and tangent. And the mnemonic that we use to remember those is SOHCAHTOA. Sine is opposite over hypotenuse, which we have here. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Now we can use these to find out the ratios of sides. And another thing that we explored in the previous lesson was that if you know the ratio of sides, you can find the angle. So if you know the angle, then you can find the ratio of sides. If you know the ratio of sides, you can find the angle. So we're going to make use of this idea to help us start solving right triangles. And remember the word solving, it's something that comes up a lot in mathematics. That just means finding the unknown or unknowns. Sometimes it's going to be one unknown, sometimes it's going to be multiple unknowns. So this first exercise, calculate the height of the triangle shown below. Traditionally, height refers to the vertical side. And I'm just going to take this opportunity to remind you, or perhaps introduce you, to the idea that when we have sides, we have a couple of options for labeling. Now, one thing we could do is we can actually label this side FE. But that's a little awkward using two capital letters. Is this F times E? There's some potential for confusion. So we actually try to avoid variables that are multiple letters. We want a single letter. In general, for triangles, the convention is you will use the lowercase letter. All of the vertices should be labeled with uppercase, with capital letters. That's a convention. And so you can use the lowercase version of the same letter across from a vertex to label sides. So traditionally, that would be D is here, F would be here, and we're already given the side E. So you could label it that way as well. And a third option is you can just label things using variables yourself. And if you're going to just label them according to whatever letters, then you're going to want to use letters that are somewhat meaningful. So for example, in this case, we're trying to find the height, so you might label that as H. Now in general, I'm going to encourage you to use the kind of the most established, the most normal convention, and that would be, in this case, I'm going to label this side D because it's across from the vertex D. So I'm going to calculate the height of this triangle. So first of all, my angle of interest is here. That's one of the things you need. You need a right angle triangle and you need an angle of interest. Right angle triangle, this means that this is my hypotenuse across from the right angle. This is my angle of interest. You don't have to write this down, I'm just putting it here. So my angle of interest is 52 degrees. And if that's my angle of interest, now I label my other sides based on that angle of interest. So 52 degrees, opposite side is down here, and this side D, which is the side that I'm interested in, that's my adjacent side. So now I'm just going to write out SOHCAHTOA. And the reason I write this out, I can use this for more than just remembering how to write out the ratios. It also helps me figure out which ratio to use. So let's take a look out of the three sides that I have available. Which sides am I either interested in or do I have values for? And as you can see here, I have the value for the hypotenuse. I want to know what the adjacent side is, that's D, and I am not at all interested in the opposite side. And so if we just go along here, I'm not interested in the opposite side, I have the hypotenuse. I'm interested in the adjacent side and I have the hypotenuse. I'm not interested in the opposite side and I want to know the adjacent side. So take a look at these pairs. Do I want to use sine? Well, I don't care about this opposite, so I don't want to use sine. Do I want to use cosine? I'm interested in adjacent and I have hypotenuse. Yes, so I want to use this one. And you can see here for tangent, I'm not interested in opposite, so I'm not interested in that one. And so for this reason, I can now say that I'm interested in the cosine. I've already established my angle of interest is 52 degrees. So what is the cosine of 52 degrees? Cosine is adjacent over hypotenuse. So for the angle 52 degrees, the adjacent is D, and the hypotenuse is 12. And that's it. All of that was leading up just to this point, and now I remember, I keep in mind, you don't have to write this. If you get comfortable with it, you don't need to write it. But cos 52 degrees is the same as cos 52 over 1. So I'm going to cross multiply. D times 1 is simply equal to D, and 12 times cos 52 is 12 cosine 52 degrees. Now, a couple of ways that you could write this. One of them is some people don't like the cosine of 52 degrees because they think, well, I don't know that this is going to help, but this is not a multiplication. We are not multiplying the cos times 52 degrees. It's the cosine of 52 degrees. This 52 degrees is what we're operating on using cosine. And another way you might write this is very much against the convention, cosine 52 degrees, and the whole thing in brackets multiplied by 12. And I'm going to put a little c here. That's poor communication. You will rarely see it written that way. Technically it's correct, but you shouldn't be writing a final answer that way. Okay, so that being the case, let's take away those kind of not necessary versions, and let's carry on with this. So we end up with D is equal to, now you can do this on your calculator in 2 steps if you want to. So I can do a calculation for cosine. And if I do that, then this becomes approximate. If you're going to do it this way, try to keep your number for your calculation in your calculator. So in my case, my calculator is now showing 0.615, and I'm going to round it. If you are forced to write it and round it, try to do 4 decimal places. That's kind of the standard, so 4 decimals. For trigonometry, it seems like that seems to be kind of a safe number to round to. But I'm not actually rounding in my calculator. I'm keeping that number, and I'm just going to take that number that's still in my calculator, I multiply it by 12, and now I'm going to write my final answer. And so since I'm going to write a concluding statement, I'm going to write this as 7.3879. And it didn't specify how many decimal places. My answer here is in meters. I'm going to do my concluding statement. I'm going to round to 1 decimal place since it's not specified. Therefore, the height is, so 7.3879, it's going to round to 7.4 meters. Okay, let's take a look at another exercise. Determine the measure of the angle J. This time I'm interested in the angle J. Now I can, once again, I can refer to just this vertex J. I can refer to it as the angle J. Or if I want to, I might want to put a variable in here. You might put a variable like x, or to get used to standard or conventions of trigonometry, you might put something like the variable theta there, which is more traditionally used for angles. But an x would be fine there as well, or capital J would be fine. I'm going to go with theta, and so I've chosen my angle of interest, that's theta. Here's my right angle, so that means that this is the hypotenuse. And with respect to this angle theta, I come across the triangle, and that tells me where the opposite side is. And I go next to theta, but not to the hypotenuse. I go to the other side that's next to theta, and that tells me the adjacent. So let's write it out. So, ka, toa. And let's see what I'm interested in and what do I have. So I don't have the hypotenuse. So I don't have the hypotenuse. That takes those away. And I do have the opposite, and I do have the adjacent. So I do have the opposite and adjacent, and of course you can see the only one of these that I can use for now is tangent. You might get a situation where you actually don't have all of what you need here. Probably would have been a better idea for me not to put the x's over the h's. So sometimes you might not have everything you need here. That means that you might need to use something else to find those values in your triangle. Since these are always going to be right triangles to start with, at least, don't forget the Pythagorean theorem, and don't forget similar triangles. Sometimes something else will allow you to find out a value. In this case, I can write tan of theta is equal to, and the definition of tangent is opposite over adjacent. So here's theta, opposite is 7, and adjacent is 8. Something we covered in a previous lesson is when you're trying to find the angle, so I'll just skip back to my previous. Here I had the angle, and so I took the cosine of the angle to find the ratio. In this case, I have the ratio, and I need to try to find the angle. So the way that I do that, if the tangent of this angle equals this ratio, then the angle itself is equal to the inverse tangent of that ratio. It's just like doing the operation in reverse. It's like when we talk about the opposite of multiplying is dividing, the opposite of adding is subtracting, the opposite of squaring is taking the square root, the opposite of tangent is the inverse tangent. And so theta is equal to, and this is something, again, try to do this whole thing in your calculator. Most calculators have brackets now, so I'm going to say I want the inverse tangent of bracket 7 divided by 8, close bracket, equals, and I can go straight to my answer here, which is 41 point, and I'm just going to round it to 1 decimal place. So theta is equal to 41.2 degrees. And if you wanted to, you might, since it actually specifically asks for the angle J, you might therefore say, therefore, angle J is 41.2 degrees. Okay? And finally, I mentioned at the beginning we talked about solve. So this word solve, sometimes that's a very generic thing. It doesn't say solve for a specific angle, solve for a specific side. Sometimes you might just be asked to solve the entire triangle, and that means find everything that's missing, angles and sides. We can use the Pythagorean theorem to back us up here. We might be able to use similar triangles if there are multiple triangles involved or different geometric properties. For this one, I'm actually going to specifically avoid using anything except for trigonometry, not because those other methods aren't valid, but because we're trying to focus on learning trigonometry right now. So let's start off with, I've got 46 degrees here. And actually, you know what? I have to point out the simple here, because I don't want you thinking that trigonometry is the only way. I've got a 90-degree angle and I've got a 46-degree angle, so I could obviously, I'm going to call this angle L. The angle L is obviously going to be part of this 180-degree sum. So maybe I'll write it this way. Let's, rather than write it as angle L, so I'll use the sides to label these. So that unknown side is small letter L. This unknown side is small letter M. And this side is small letter K, but it's already known. And then I've got one unknown angle, so I'm going to label that theta. So the angle sum theorem says that the three angles in a triangle, theta plus 46 degrees plus 90 degrees, well, they are going to add up to 180 degrees. So that means that theta plus 46 degrees equals 180 minus 90, which is 90 degrees, or theta on its own is equal to 44 degrees. And that's awfully simple. Like, you want to do that if that's an opportunity. I'm going to use trigonometry. Once we're done here, I'm going to use trigonometry to show that I get the exact same result there. And I'm going to talk a little bit about rounding as well. So let's talk about sides here, and let's focus on 46 degrees. So 46 degrees, I think I'm going to change this to a red theta for later when I'm working with opposite and adjacent. So for 46 degrees, let's see, here's my right angle, which means that this side M is always the hypotenuse. For 46 degrees, this is the opposite, and this would be the adjacent. So let's take a look. So ka toa. And so I'm actually interested in, so first of all, the hypotenuse. Am I interested in the hypotenuse? I am. So that gets question marks. I know the opposite, so that gets check marks. And I'm interested in the adjacent, so that gets question marks. So I take a look at overall, which of these can I do? I can do the sine, and I'll use that to find the hypotenuse. I could use tangent, and I could use that to find the adjacent. The one thing I can't do here is cosine, because I don't know either of those two things. So let's go ahead and use sine to find the hypotenuse. So I get the sine of 46 degrees is equal to opposite over hypotenuse. So opposite is 8, and the hypotenuse is the letter m. Now this is a cross multiplication situation, but it's actually, we're going to do it a slightly different way, because notice I've got 8 times 1. The variable is actually getting multiplied by sine 46 degrees. And just like if this was a number, we're going to write that in front. So I'm actually going to write this as m sine 46 degrees is equal to 8 times 1. That's just equal to 8. Now I have to admit at this point in time, some students can get a little frazzled by this. And there's a couple of concepts to keep in mind here. The first one is that sine 46 degrees all together, don't get intimidated by that. It's just a number. If you put that into your calculator, it's going to be some decimal. So if I want m all by itself, I'm going to divide by this number, whatever it is. You could turn it into a decimal right now, make your equation approximate, but I would encourage you to try to just get yourself comfortable with the idea this is a number. I'm going to divide both sides by that number. And when I do that, I end up with m is equal to 8 over sine 46 degrees. M is approximately equal to, and now be careful doing this. You want to use brackets if you need to. 8 divided by the sine of 46 is equal to 11 point, and now we have to be careful here. Am I going to use this number for subsequent calculations, or am I just reporting a final answer here? So I'm going to use 4 decimal places for now, but that's still not my preference because it's still rounded. I've still lost precision. But let's leave that for now, and I'll come back to that idea of precision. Okay, so now I have found the hypotenuse, but I'm still interested in the adjacent. So let's find tan of, once again, 46 degrees is equal to opposite over adjacent. The opposite side is still 8. The adjacent side is labeled with the letter L. We're going to cross multiply. This is over 1. Cross multiply just like before. L tan 46 degrees equals 8 times 1, which is 8. We divide both sides by tan 46 degrees, so I end up with 8 over tan 46 degrees. And again, using my calculator, I take 8 divided by the tangent of 46 degrees, and I end up with 7 point, and I'm going to do 4 decimals again, 7255. So I have found m and I have found L, and that's it for my side lengths. But I told you I was actually going to show you again how to find this angle using trigonometry. So the way these are right now, these are fine, and I could say m is approximately equal to 11.1. I could say L is approximately equal to 7.7. And that's all well and good. That's fine. And I've already found my angle, 44 degrees. So I've solved this triangle. I don't want you thinking you have to do any more work than this. But I want to go back, and I actually now want to try to find this angle using trigonometry. So I'm going to switch over to red. If I switch over to this as my angle of interest, the hypotenuse is still the same, but now this is the adjacent side, and this is the opposite side. Now, if I want to find theta, I'm going to use the adjacent side, but I actually still have the problem with L and M. They're not known. But they are known now because I solved for them. So I can actually use any trigonometric ratio to find theta. So I'm going to use, let's see, I'm trying to find theta, so I'm going to use cosine because we haven't used cosine yet. So the cosine of theta is equal to the adjacent, and we're in the red now. This is still hypotenuse, whether it's red or blue. Cosine is adjacent over hypotenuse. That's from here. Cosine is CAH, adjacent over hypotenuse. That's going to be 8 divided by m. So cosine theta is 8 divided by m. But we know what m is because we calculated it. So that's 8 divided by. Now this is, actually, you know what, before I write that, rather than going and taking this value of m, even this value with 4 decimal places, if I were to do this with, actually, I'm going to show you this. What if I put in the value with 4 decimal places? So this is approximately 8 divided by 11.1213. And so theta is equal to the inverse cosine of 8 divided by 11.1213. That's approximate. And when I put that in my calculator, being careful, I take the inverse cosine, and I'm going to use a bracket to do 8 divided by 11.1213, close bracket, equals, I get an answer of, and this is right from my calculator, 43.99995344, approximate, and that's degrees. And hopefully you see the problem with that, which is, even though it's pretty close to 44, it's incredibly close to 44, up here there was no rounding at all. The answer is exactly 44. So how can we improve upon that? Here is the other option. Cosine theta is equal to 8 divided by m. And so now what I'm going to do is I'm actually going to, cosine theta is approximately equal to, I'm actually going to do this calculation in my calculator again. Right here, this is how I found m. So I'm going to go to my calculator, I'm going to put 8 divided by the sine of 46, and that's in my calculator now. I'm not going to round it. And then I'm going to, if I'm good at manipulating my calculator, I'm going to say 8 divided by that number that I just got, and I end up with, actually, it's not approximate. I end up with an exact value here, and it's actually exactly equal to 0.7193398. That's not going to happen very often, but it happened here, which means theta is equal to the inverse cosine of 0.7193398. And when I take the inverse cosine of that, I end up with inverse cosine of that value is exactly 44 degrees. No rounding, not approximate. So if you have the calculator skills, you could do it that way, you should do it that way. And if you don't have the calculator skills, you should take the opportunity to practice these things when you have the chance. So there is an example of me completely solving a triangle for 3 different unknowns. And I think that's it. So there's the homework associated with this lesson.